Hi, good afternoon. Thank you for joining us today. I'm Joan Woodward, president of the Travelers Institute, which is the public policy division and educational arm of Travelers. So welcome to Wednesdays with Woodward, a webinar series where we convene leading experts like we have today to talk today about the biggest challenges facing us in our personal lives and our professional lives, of course. So before we get started with today's program, I'd like to share our disclaimer about the event. So a big thanks to our partners today for the program, the MetroHartford Alliance, the American Property and Casualty Insurance Association, and the Masters in FinTech program at UConn School of Business. So thank you and welcome to all of our members, students, and alumni. We really appreciate you joining us today. As many of you know, June 1st marks the beginning of the Atlantic hurricane season, which runs through November the 30th. For insurance professionals, but more importantly, for all of those who live near the Atlantic coast, it could be a really unnerving time. We're coming off the 6th consecutive above normal Atlantic hurricane season, with last year being the 3rd most active year on record in terms of named storms. So every year, the World Meteorological Organization prepares a list of 21 potential hurricane names for the named storms. So for the first time ever, we've had 2 consecutive hurricane seasons where all 21 names were used. And this begs the question, what can we expect for the 2022 and beyond? So unfortunately, we don't, and not does anyone, have a crystal ball really to see the future, but we do have the next best thing with us today. I'm joined by 3 leading authorities in hurricane forecasting and risk mitigation today. So we're going to spend the next hour exploring the latest advances in hurricane modeling, forecasting, and mitigation to help insurance professionals, businesses, and communities, all of us, better understand and prepare for these hurricane risks. So we have 3 fantastic speakers joining the program today, and let me introduce them. First up, we have Eric Nelson, my colleague and friend, who's Senior Vice President of Enterprise Catastrophe Risk Management at Travelers. Eric coordinates the evaluation of risk and partners with our business units really to develop pricing and underwriting strategies related to CATs. In conjunction with his role at Travelers, he also served as chairman of the board for the Insurance Institute for Business and Home Safety, IBHS. Eric is an advocate for coastal mitigation strategies and really has been leading the way. Has testified before Congress on the benefits of strengthening building codes. And so we're really grateful to have you with us today, Eric. Next up is Dr. Phil Klotzbach, a research scientist in the Department of Atmospheric Science at Colorado State University. Phil holds a PhD from CSU and has worked in the Department of Atmospheric Science for the past 21 years. If you ever read about hurricane forecasting in the news, chances are Dr. Klotzbach has something to do with them. He's world-renowned in this space. He's a co-author of CSU's Atlantic Basin Hurricane Forecast through 2005, and in 2006 became the first author of CSU's Seasonal Hurricane Forecast. So throughout his career, he's authored over 90 articles in peer-reviewed journals such as the Journal of Climate and Weather and Forecasting. Finally, today we're joined by Karen Clark. Karen is the co-founder and CEO of Karen Clark & Company, a leading authority on catastrophe risk assessment and management. Karen founded the first CAT modeling company and is credited with creating the CAT modeling industry. So catastrophe modeling techniques and innovative technologies she pioneered decades ago, revolutionizing the way insurance companies like ours, reinsurers, and other financial institutions assess and manage their CAT risk. She's incorporated this CAT modeling into Karen Clark & Company and produced more transparent and accurate models for multiple innovative technologies. And she was most recently named the 2021 Catastrophe Modeling Firm of the Year by Inside P&C magazine for precision, accuracy, and successful innovation in science of catastrophe risk modeling. Karen also has been recognized for contributions to the insurance industry. And just to name a few, she was awarded Women of the Year by the Association of Professional Insurance Women. She was honored with an award certificate for the 2007 Nobel Peace Prize bestowed on her Intergovernmental Panel on Climate Change. So we're really thrilled to have you with us today. Karen, Phil, and Eric. To begin our conversation, I'm going to ask each of our speakers to give us kind of a high-level brief overview of what they're seeing for the hurricane season this year. And then we're going to have a moderated discussion. Put your questions in that Q&A feature. We're definitely going to get to those at the bottom of the show. So Eric, welcome to our virtual floor, and we'd love to hear your thoughts on the hurricane season.
Great. Thank you so much, Joan, for that introduction. So we're going to talk about the evolving risk landscape. And so what I'm going to do is just talk about some trends before I turn it over to Phil to get into the specific forecast that I know we're all interested in hearing about. So let's just talk about long-term trends. And so what you see on the graph here in front of you is industry economic losses from events greater than $1 billion. And what we tried to do here is show the trends over time. And so when you see the trends over time, you can see they're increasing rather significantly. And as Joan did a great introduction to talk about the recent events, but I just want to talk about some of the factors that are leading to this increase. Well, it's certainly a population migration to higher risk areas. We know inflation does impact the numbers. We're all feeling that today, but also the aging infrastructure that plays into what potential losses can be. Building code adoption and enforcement. Most people do not realize we do not have building codes in every state in the country. Hard to believe, but we don't. And so we also have less effective enforcement of building codes in some areas. We're also a very prosperous country. And so sometimes when you get a major event, you might have post-event demand surge. Contractors already, in today's economy are employed quite well. There's even shortages in some spots. And so when you have post-events demand surge, you're trying to go after a smaller pool of contractors. Regulatory changes can occur. That's fine. Regulators try and do something that they view as in the best interest of their consumers. But at times that regulatory change does increase the cost over time. And the last one that Karen's going to touch upon a little bit in her conversation is weather volatility and climate trends. So all that factors into why we're seeing increase in losses over time. A little bit about the population growth change, because this is probably the biggest impact that's occurred over time. And so what you see about is just an example on the left from 2010 from the Census Bureau to 2020, talking about the states with the highest growth. And so you can see that's Texas, Florida, and South Carolina. Apparently, for those of us like me that live in the Northeast and are looking for some sun one day, there's a big migration down to the South at times. Beautiful weather, low tax environments. And so if you look at Florida, it's more than doubled its population in the last 20 years. Majority of the population now lives in coastal areas. Since 1980, 71% of the overall population increase is driven by coastal states. And then lastly on there is estimates put Florida migration as about 850 new residents a day through 2026. So if we go to the next slide, I'll explain why does this matter. And so if you look over to the right, let me just start with that. If you look over to the right and you look at the historical numbers on economic losses, about 40% has occurred in Florida and Texas over the last 20 years. If you unpack that a bit, though, you have to recognize from 2006 to 2015, we really had a drought of hurricanes, not many hurricanes occurring in Florida. And so if you think about that more on a normalized basis, Florida was lucky for that period. If you think about a more normalized basis of what you expect a lot more hurricanes to impact Florida over time. And so probably on a prospective basis, I would guess that more like 2/3 of the potential losses will occur in Florida and Texas, absent of that continued population migration. So what I'm trying to say is Florida and Texas have a much higher likelihood of severe hurricanes. And so therefore, as more and more of the US population shifts to those areas, as a country, we're now going to see more hurricane losses. If I move over to the left for a minute, let's just put hurricane or tropical cyclone in perspective. And again, this is 1980 compared to 2021, just $1 billion events or greater adjusted for inflation over time. Well, tropical cyclone has represented about 61% of those losses. And for example, severe storm, tornadoes, hail, severe wind has been about 18%. If you were to normalize this for all types of events, even below $1 billion, we're talking about maybe about 40% would be from tropical cyclone and about 40% from those severe storms. So this just gives you a perspective. Tropical cyclones, again, big events make up the majority of the economic damage we see. If you adjust it, it becomes a little bit smaller as a portion of the total. Let's go to the next slide. So, we talked about this a little bit. Let's do one more click. And so if you look at the losses that have occurred over time, everyone can think about Harvey, Maria, Sandy, Ida, Irma, Michael, the big events that have occurred over the last 10 years, and those are the red lines. But if you think about the black lines are where landfalling events have occurred in the United States. And it's really what I'm trying to display with this graph is it's everywhere. You have a potential across all states, I'm saying. You have the potential to see hurricanes in all states. You can look at the damage that's occurred in the Southeast and the Gulf that we've all heard about, but there's also events that have hit as far up as New England. So none of us are immune to hurricanes and tropical cyclones. And with that, if we click to the next slide, I'm going to turn it over to Phil to go through the forecast to give us some impression of where we think we're going. Phil, I'll turn it over to you.
Thanks so much, Eric. So we at CSU put out our first forecast on April the 7th, and we'll actually be doing our next hurricane forecast. We're putting out tomorrow at 10 a.m. Eastern. So I'll talk about the April outlook, and I'll discuss a little bit about kind of what we've seen since the April outlook in the next few minutes. So our forecast that we put out on April 7th was for an above normal Atlantic hurricane season, predicted a total of 19 named storms. Those are systems named by the National Hurricane Center, winds of 39 miles per hour or greater. Of those 19, 9 becoming hurricanes, and of those 9, 4 becoming major category 3, 4, 5 hurricanes with winds of 111 miles per hour or greater. That compares with the average season, which has about 14 storms, 7 hurricanes, and 3 major hurricanes. One thing I did want to point out too is we also forecast an integrated metric known as accumulated cyclone energy. That's an integrated metric that accounts for storm frequency, intensity, and duration of storms. So you may hear myself or others discussing accumulated cyclone energy. Just that gives you a little bit of an idea as to what we're predicting there. So now if we can move ahead to the next slide. I'll talk a little bit about kind of what we currently see. And so some of these features are similar to what we saw with the early April forecast. And there's been a few changes as well. So here are current basically sea surface temperature anomalies or differences from the long-term average. So kind of the way you would expect, blues mean colder than normal, oranges and reds mean warmer than normal. And if we look at these two rectangles, these are kind of highlighting two of the areas that we really focus on during the peak months of the hurricane season. The red rectangle is what's known as the Atlantic Main Development Region. That's the area where most tropical cyclones form in the Atlantic. And the blue rectangle is kind of what we monitor to kind of assess the state of whether we have El Nino or La Nina. So La Nina is colder than normal water in that rectangle. El Nino is warmer than normal water in that rectangle. If we look at the Atlantic, we can see warmer than normal waters, a lot of them in the not necessarily in the tropics, but farther north into the subtropics and middle latitudes. And I'll discuss why that's important a little bit later. But first of all, let's focus on the tropical Pacific. So if we can advance to the next slide. If we focus on the tropical Pacific Ocean, that blue rectangle highlights what's known as the Niña 3.4 region. Not a particularly exciting name, but that is the region that NOAA uses to basically monitor the strength of either El Nino or La Nina. So when temperatures in that box are 0.5 degrees Celsius colder than normal or more, NOAA will declare a La Nina event. You know, half a degree Celsius, 1 degree Fahrenheit, that's not much. But small temperature changes in the ocean can make big differences in how the atmosphere then responds. So you tend to get fairly small temperature changes in the tropics, but the atmosphere can have big changes in how it responds. So if we have a La Nina, what that tends to do is it tends to create wind patterns high up in the atmosphere, 20 to 30,000 feet, that are more conducive for hurricanes. Alternatively, when you have an El Nino, which is basically the opposite of La Nina, so warmer than normal water in this rectangle, that increases winds high up in the atmosphere that tend to tear apart hurricanes. And that's one of the first features that Dr. Bill Gray noted when he started doing these seasonal hurricane forecasts all the way back in the early 1980s. So now we're talking about late May, but a lot can still change between now and the peak of the Atlantic hurricane season. While today's the official start of the season, it really doesn't ramp up historically until August. Over 90% of your major hurricane activity occurs during the 3 months of August, September, and October. So if we move to the next slide, we can look and see what we have for current outlooks for El Nino and La Nina going forward. So this is the early May outlook. This slide will actually be updated next Thursday with the new NOAA outlook. So NOAA for August through October, the peak months of the season, gives less than a 5% chance of El Nino. So unfortunately, we do not think El Nino is going to be present. Again, El Nino tends to tear apart hurricanes. Whereas this year it looks fairly likely like we'll have La Nina. We may also have what's known as neutral conditions, which means water temperatures near average in the Pacific. And then really what matters is what's going on in the Atlantic. If you have neutral conditions, the Pacific isn't necessarily going to be as impactful of a region for what goes on in the Atlantic. But if we move along to the next slide, you can see kind of why NOAA, with their most recent outlook, said there's really low chances for El Nino. So these are a whole pile of different models. If you like acronyms, certainly there's alphabet soup there for you on the right. Here's all these different models for August through October. Most are calling for, or basically none of them are calling for El Nino for that August through October period. You can see none of those lines are above the El Nino threshold. About half are calling for neutral conditions, but most of them below zero. So that's known as cool neutral or La Nina conditions. And overall, the cooler the waters in the tropical Pacific, in general, the more active the Atlantic hurricane season. So now moving on to the next slide, I just briefly wanted to highlight the Atlantic because obviously that's where the hurricanes are. So warmer than normal water in the tropical Atlantic is conducive for an active hurricane season because it provides more fuel for developing tropical storms and hurricanes. But if we look at the current sea surface temperature pattern, you see the tropical Atlantic's a little bit warmer than normal. But if we look farther north in the eastern part of the Atlantic and the subtropics and the middle latitudes, there's a lot of warm water there. And that's really important. When you have water temperatures there that are warm in April, May into June, what that tends to do is it tends to cause lower atmospheric pressures. It weakens a semi-permanent area known as the subtropical high. That high pressure gets weaker, and consequently the winds blowing across the tropical Atlantic, known as the trade winds, are weaker. Those weaker trade winds tend to cause less mixing and churning up of the ocean surface, which warms the tropical Atlantic, providing more fuel for storms during the peak months of the hurricane season. And we can see that if we move along to the final slide from my presentation. Here's a plot showing sea surface temperatures during the month of June correlated with Atlantic accumulated cyclone energy, that integrated hurricane activity metric. You can see where the dark reds are is where the correlations are the highest. And you can see there's a lot of high correlations off of the west coast of Portugal, even all the way up to France and England. So again, those warmer waters there this time of year tending to lower the pressures and then leading to weaker winds blowing across the tropical Atlantic, making likely for a more active Atlantic hurricane season. And we'll have a lot more to say with our updated outlook, which is again coming out tomorrow, June 2nd at 10 a.m. Eastern. And so with that, I'd like to turn it over to Karen Clark.
Thank you, Phil, and hello, everyone. And also thank you, Joan, for that very kind introduction. I'm very happy to be here participating in the Travelers Institute. And I'm going to go back to talking about losses. Dr. Phil, hopefully you don't mind, I'm going to call you Dr. Phil, took us through the forecast for the year with respect to hurricane frequency. And what I'm going to talk about now is what we can expect or what the outlook is for losses back and specifically on insured losses. So if we start with this graph, this is a historical perspective, but it might be a little bit interesting to you. It goes back to 1900, you can see on the x-axis. And what it's showing are what the insured losses would be today if the most severe hurricane from each of those years were to happen today. And what you can see immediately is the tallest bar is from 1926, and that's the Great Miami Hurricane of 1926, which was a Category 4 that made a direct hit on Miami. The other interesting thing you could see here is that the other three of the other five are also in Florida: the Lake Okeechobee, the Fort Lauderdale, and Hurricane Andrew. And what you also notice is that most of them are in the earlier time period. And of course, this may be counterintuitive because you always hear on the news, we have record-breaking losses. It seems like every hurricane causes record-breaking losses, every major one. But of course, that's because of what Eric talked about earlier, which is the increases in population and property values. So again, if we go back to 1926 in Miami, I don't think there was much there. Miami was probably pretty much an extension of the Everglades. But of course, today, if that storm hits again, the losses are going to be about $160 billion. So, and you can see that, Hurricane Andrew, which happened in 1992, because of the growth since then, would be almost 70 billion, when at the time it was 15 billion. Now, the reason I show this is because we tend to think of frequency as highly correlated with losses. But it's not really, I mean, frequency is of course important, but you can see the last 5 years, they are lower bars than these other years where we had a major event hit a populated area. So we can go to the next slide. What we see, what I like to say, those of you may know, what are the three most important things for real estate? It's location, location, location. So I like to say hurricanes are like real estate. It's all about location. So insured losses depend not so much on how many hurricanes we're going to have in a year, but where they make landfall. Now on this chart, we're looking at industry losses from the 100-year hurricane. Now let's talk first about what is the 100-year hurricane. Scientists, insurers, we like to talk about return periods, 100-year, 50-year, 1,000-year. But that can be misinterpreted because by the 100-year hurricane, we don't mean the hurricane that's going to happen like clockwork every 100 years, but we actually mean the hurricane with a 1% chance of occurring this year. And what's also important to keep in mind is that sounds like a low percentage. It's only 1%, but that's in 1 year. Over 10 years, we have almost a 10% chance of having that hurricane. So this is not an extreme event that we should think won't happen. It will happen. The question is when, and insurers need to be prepared. So if we look at this chart, this is looking at the 100-year hurricane, and we can see the peaks are, of course, where we have populated areas, Galveston, Houston, and Miami. In both of those areas, the 100-year hurricane would cost over probably $250 billion, and that's insured. The next biggest peak is in Tampa. You have New Orleans in the Northeast. Now, some of you may be asking, well, why is the Northeast only 100 billion? Wouldn't that be Cat 5 hitting New York City, and wouldn't that cost more? Well, the answer to that is that the 100-year hurricane is not the same intensity all along the coast. It would be a Cat 5 along the Gulf and in Florida, but in the Northeast, the 100-year hurricane, because the water temperatures are cooler, we don't expect a Cat 5 or even a Cat 4 with that frequency, would be a Cat 3 in the Northeast. The other thing to look at on this are the red bars. I've highlighted Panama City and Homestead. Why Panama City? Well, that's where Hurricane Michael hit in 2018, which was a Cat 5 hurricane. So you can see we don't hardly even think of Michael. Of course, people in Panama City do, but the losses were on the order of about $15 billion insured, where you see if that had been any in other places along the coast, say around Tampa, the losses would have been much higher. I also have Homestead highlighted, which is where Hurricane Andrew made landfall. So again, you can see if Hurricane Andrew had hit only about 50 miles north, the losses would have been 4 times higher. And I didn't mention what the x-axis is here, but it's, of course, you can see its landfall location, and each bar is at each 10 miles along the coast. So if we can go to the next slide, please. So now let's talk about the future. And of course, what's on most of your minds is climate change. How is climate change going to impact hurricane losses in the future? Well, let's start with global temperatures. How much have they actually increased since 1900? And you can see on this chart that while there is fluctuation from year to year, the trend line has been about a 1.1 degrees Celsius increase in temperature since 1900. Now, what does that mean for hurricanes? Well, scientists that study this have concluded that a 1.1 degrees Celsius increase leads to about a 2.7% increase in hurricane wind speeds. Now, again, that doesn't sound like a lot, but losses increase exponentially with wind speed. So you will see in a little bit that losses do increase a lot more than you would anticipate from that. So that's what we've seen to date. If we can go to the next slide, we'll see what that means in terms of major versus non-major hurricanes. First of all, if you look on the left of this, what I'm showing here are the number of hurricanes going back to 1980 that achieved, not necessarily at landfall, that achieved somewhere in their life cycle over 170 mile per hour wind speed, which is actually an extreme category 5. And you can see that this is happening more frequently. So this is how scientists believe that increase in wind speed is going to be manifested, which is more intense storms. You can see Dorian, Irma, Katrina. And if you look over on the right, what that means is if you look historically, all the way back to 1900, the data, you'll see that about 32% of hurricanes are considered major, category 3, 4, and 5. But if you adjust the historical data for the global climate trends, the major jumps to 36%. And so what you can see is that there's a shift from the category 1s and 2s to the 3s, 4s, and 5s with climate change. And of course, that is going to impact losses. So that's to date, again, so what about looking ahead on the next slide? So how do we know what's going to happen in the future? Well, of course, we don't know with certainty, but what the Intergovernmental Panel on Climate Change has done, that's the global body of work of the scientific consensus around the world. They've come up with, in their most recent report, what they call SSPs, Shares Socioeconomic Pathways. And what those SSPs depend on is what happens with emissions, with greenhouse gas emissions. So of course, that depends on what we're going to do as society. So they have different scenarios, starting with 1.9. I'm not going to go into the science, what radiated forcing means, but you can see that as that gets higher, that's worse. So at the kind of 1.9, it means that we are going to achieve net zero emissions by 2050. So that's a great scenario, and we do whatever we need to do that. On the other extreme is 8.5, where we have rapid global economic growth. We keep investing in fossil fuel. We basically do nothing. 4.5 is about a middle of the road, where we're largely business as usual, but we are making strides with our more sustainability goals. And what you can see on the right is how scientists have projected out the temperature increases under those different scenarios. So what we do as a catastrophe modeler is we take all this science and what the consensus is with respect to temperature changes in the future, and then we can apply that. If we go to the next slide, please, we can apply that to what will happen with the wind speed increases. So there are a lot of numbers on this chart, don't worry about that. But we project out to 2025, 2030, and 2050 under 3, the best case scenario, worst case scenario, and middle of the road scenario for these SSPs. And you can see the temperature increase on the left 3 columns, and then what that means for wind speeds on the right. And so we build that into our models, and we can come up with the loss projections. Well, first of all, if you go to the next slide, please, we'll see what that means with respect to the shifting, as I said before, from weak hurricanes to the more major hurricanes. And these colored bars are all correspond to the 2025, 2030, and then the 3 different scenarios for 2050. So we first go back to our hurricanes and we make the shift to intensity, and then we can see what happens with losses. So if we go to the next slide, we can see what happens to our losses first for 2020 and 2025 and 2030. Now, some of you may not be that familiar with catastrophe models. So very quickly, the models give return periods of losses of different sizes. So here we're showing the 5-year, the 10-year, the 20-year, all the way up to the 250-year return period losses, corresponding, as I said before, for example, to the 100-year return period. We have the 10-year and the 5-year return period. So these bars are showing the percent change in losses. And what you can see very clearly is that the bars are rise higher at the lower return period, the 5 and 10-year return periods, more than the 100-year. Now, what that means is that we're going to start seeing a lot more 20, 40, $50 billion hurricane losses, because this is where we're going to have more severe storms everywhere along the coastline. So we shouldn't, I mean, a 10-year, just to put it in perspective, we should be expecting a 10 billion hurricane loss about every other year, and a $40 billion loss about every 10 years. So we shouldn't be thinking about these large events, Ida and Laura, as extreme events. This is what we will be seeing with a lot more frequency, again, with climate change. My last slide just takes it out to 2050, which there is a lot more uncertainty, but you can see there's also uncertainty on those SSPs, and the loss increases will depend on how effective the global societies, global economies are in holding down those greenhouse emissions. Now, one final point I'd like to make is that this is just the increase due to climate change. And while that's significant, as Eric said in the beginning, population continues to move to the coastal areas. So the increases we're going to see out to 2050 due to pure exposure changes will actually dwarf these. So we're likely to see at least a doubling of losses due to exposure changes, given current trends, not just in population, but in building construction costs and the sizes and values of properties that we're essentially building in harm's way. So I'll leave it there. And I think Eric is going to come on now and talk about how we might be able to mitigate some of these losses.
So boy, dire predictions at times, but I do think it's within our control. We can decide where we want to live. We can decide how we want to live. And so I want to just talk about narrowing the path of potential destruction. The National Institute of Building Science estimates the cost benefit ratio of building an IBHS. So that's the the Institute for Business and Home Safety, has a standard that they talk about, Code Plus. I'm going to talk about that in a minute. But talking about that building a mitigated home for hurricane has a 5-to-1 cost benefit ratio. So mitigation is a way we can considerably lower the amount of potential damage that occurs in the country. And just a plug, go beyond just thinking about reduced insurance costs. Put that aside for a minute. It's about preserving the way you live. It's about preserving your communities. It's about preserving all of those mementos you have. It's about life safety. And so we in this country could decide to build homes and buildings much more resilient than we are today. And so beyond building, that's new construction, right? And even on retrofit, there's some things that you can do that we'll talk about. But there's also something that you can be prepared for an event. So there is things that you can do as we go into hurricane season. I just want to remind folks, you can go on Travelers Prepare and Prevent website. Many insurance companies also have websites on how to be prepared for hurricane season. So my quick tips are, make sure you have a plan. Do periodic checks of your insurance coverage. Close the openings that are out there. Do pre-season cleaning of gutters. Prune back your trees. That's so important. Prune back your trees 10 feet away from the house. And of course, secure any outside items. That patio furniture is a flying projectile in hurricanes. So make sure you put that furniture away. And so if we talk about mitigation programs and resources, I also want to stress that the states are really, really putting their step forward on this. There's My Strong Home programs in several states. There's a Strengthen Your Roof program that's been available in the past. Some of these are awaiting future funding or additional funding, but North Carolina's had a great program. South Carolina's had a great program. There's also nonprofits that are out there. And so there's many different mitigation programs out there, and this list just keeps on getting longer and longer. And so let's talk about mitigation in a little bit more detail. Go on to the next slide. And so if you go on disastersafety.org, that is IBHS's website that talks about a fortified home. And a fortified home is based on 20 years plus of storm damage data. The scientists at IBHS and the insurance industry have been studying this a long time. And we've developed standards that are stronger than the typical building codes. So superior to building codes, we can build homes that are more resilient. Go to the next slide. And so this program, we have a fortified roof, talking about improving the resiliency of your roof, fortified gold, fortified silver. So that's just different degrees of what you can do when you're building your home. And so that program has been out there for several years, and we've had a great success. So we've had 38,000 homeowners have taken advantage of this program and built more resilient. Now, if you look in a little bit more of the details, you can see Alabama is by far the states that's gone the furthest, because one, in a lot of the coastal communities, they've now adopted those standards. Two, they set up the education for their builders, for their realtors. And three, they have the programs to back it up. And so I'm very pleased with how the Gulf Coast states, especially Alabama, has moved towards embracing this Code Plus. And I'm going to show you what that means in a minute. But typically, a fortified roof cost is typically $1,000 to $3,000 of additional costs. And what that's going to do, just to describe the roof, because I've actually done this on my own house, is you're going to tape the seams when you think about when the plywood comes together. So what happens is, and you also put on an additional water barrier. And so if your shingles fly off, you almost have that second layer of defense to prevent interior water damage. And believe me, from my own personal situation, it came in so handy in a New England storm where my shingles blew off. I greatly reduced the amount of damage that I had in the house from that. And so if you go to the next slide, we want to just show a video. Let me just show, without going through all the details, you can read the website on that. A video is worth so much more than the words. So let's hit it and let's show the video here. And so this was actually the first test that I ever saw at IBHS. And what you saw here in the video is a home that's built on the left-hand side to typical construction standards. And you can see the significant damage. This is the IBHS lab down in South Carolina. I call it Mother Nature in a box. We can create hurricane force winds and test the building resiliency. So I'm very proud of what that organization has been able to achieve in developing standards for Code Plus, and they've proven to work. So please go check it out. Fortified.home, disastersafety.org, two different websites. They have both. So some great information there. So with that, Joan, turn it back to you for any questions and moderation you want to do.
Thank you. Thank all three of you. And please come back on camera. We are just so lucky to have your insights over the last half hour. So just fascinating slides and lots of interest here. So I have a couple questions myself before we get to some audience questions. Dr. Phil, so you said tomorrow we'll expect an update to your April forecast. So in 3 months, what changes? So in April 2022, you made these forecasts about how many and how severe they might be. So in 3 months, is it basically the climate, the temperature of the waters changing? What else are you looking for to make your changes, your tweaks, shall we say?
Yeah. So we do, as you mentioned, we'll update the forecast tomorrow. And so one of the big things that we look at, especially during the spring, is, how are things transitioning with La Nina? So often, if you're going to get a transition from La Nina to El Nino or El Nino to La Nina, it happens during the spring. And so there's a phenomenon known as the springtime predictability barrier, which is loads of fun when you're trying to do seasonal forecasting. It's really hard to predict El Nino during the spring. That predictability barrier is thankfully coming towards an end, and it really does look like, unfortunately for the hurricane season, that we won't have El Nino conditions. So, like I mentioned before, the update comes out tomorrow, but certainly we don't think the numbers are going to be going down. The odds of El Nino just are lower even than they were during April. Also, when the Atlantic in early April, the tropical Atlantic was actually a little bit cooler than normal. Now it's a decent bit warmer than normal. And these slides, I sent in, were about a week old now. And even since then, there's been some additional warming faster than normal. I mean, obviously the Atlantic always warms up from winter to summer, but it's warming up faster than normal. So, with that, again, we don't expect to be reducing our numbers tomorrow. Overall conditions, unfortunately, look like another busy Atlantic hurricane season. However, just because it's even if it is a perfect forecast and it's a busy season, in general, more active seasons have more landfalling hurricanes, but you can get lucky and have a year like 2010, where we had 12 hurricanes in the Atlantic basin and not one of them made U.S. landfall. On average, it's about 1 in every 4 hurricanes that hits the continental U.S.
1 in every 4. Okay. Eric, I want to talk to you a bit about you've been at Travelers a number of years now, and your job in looking at risk and looking at the models that come out for our own internal purposes. You're helping our underwriters price our products as you look through all the models. What are you really focused on when you're looking at the models and these storm-related losses, the insured losses that we see every year? How has that kind of evolved for you and your job over these years?
Well, it's certainly, for not just my job, I would say my team and the teams at Travelers that look at this, not just my team, the teams in the business and claim department. I think what you have to understand is the world is becoming increasingly uncertain. And so in the past, we may have relied upon a vendor point of view to understand the risk, because as Karen talks about this, it's very complex. But what I've done now over time is we want to get a lot of different opinions of this. And that's where both Phil and Karen, we've expanded our relationship with other outside experts to get their opinion and get their understanding, as well as we've hired our own meteorologists in-house to really make sure we understand things. And we've spent a lot more time thinking about the consumers and thinking about what should the consumers do, and how can I get that question when I was traveling the field in past jobs, how can customers reduce the risk? And so we've really partnered as an industry to think about those questions. How can we reduce risk? And that's where IBHS is key.
Great. So Karen, you've been at this, you're the mother of modeling. We heard in your introduction. Other than insurance companies like ours, who else uses your models, and what do they do with looking at all of these granular forecasts that you put out? Are there regular bigger companies or governments looking at this? How do you interact with kind of non-insurance groups?
Sure. Well, first of all, Joan, for the insurance industry itself, I mean, catastrophe modeling, not just for hurricanes, but Eric mentioned all these other perils we have. It's really the global standard way that insurers and reinsurers price, underwrite, and manage risk. So that I talked about this EP curve. It includes like a lot of metrics that you need to understand and manage risk. But yeah, it's getting, I would say, like climate change is having an impact on the types of industries that are demanding this type of modeling, because it's been very surprising to me. But last week I was at the Bermuda Climate Summit, and so there were a lot of consulting firms there and government officials and from the US Treasury, what have you. And they, it seems like, we take cat modeling for granted. Eric's like, well, yeah, we've done that for decades, but other industries do not have this, this very rigorous framework. And that's what it really is. I mean, it's a very rigorous framework for taking events, what are their intensities, what'll be the damage, what'll be the financial implications. So it's this amazingly powerful technology that it's just opening eyes. And I think, other industries, all industries, they really didn't think they needed it, but now when they're being required through ESG to account for climate risk, they're seeing that this would be a very beneficial technology for them to be able to tell their shareholders, their production facilities around the world, how vulnerable are they to tropical cyclones, to earthquakes, to sea level rise. So we're seeing that there is going to be a very big expansion of this technology that really the insurance industry started, really embraced from the beginning, because of course, I mean, the insurers, we enable economies to thrive and survive, right? Because we basically protect them from extreme event risk. So, so it's definitely expanding in terms of the users of this technology, Joan.
Okay. Is there room for improvement then, Karen? What are the potential innovations down the road for you in your models? Is there an ingredient or some piece of the puzzle that you don't have a clear picture of in your modeling? Or what could we expect over the next 10 years for the industry to evolve?
Well, sure. Well, they can always be improved. And of course, that's what the KCC scientific and engineering teams are always doing, is improving them. And of course, the science of these hazards, you can see Dr. Phil, he's forecasting. I mean, scientists, we understand the kind of the science pretty well. Obviously on the vulnerability side, as Eric says, that's changing all the time. So when events happen, we get a lot of claims data that enables us to bring any learnings from that into the model. But the biggest challenge really, where there are the unknowns, is what I already talked about, is climate change. Everyone wants to know exactly what's going to happen in the future. And for that, there is a lot more uncertainty. But I think the challenge is, as I said, not just for insurers, but for all these industries, give them a template they can work with. There's a lot of confusion, like, do we take 2030 or 2050? Which SSP do we look at? So I think there is a need for kind of a standard, like this is what we're going to look at, knowing that it's uncertain and knowing that we're going to have to update our models a lot more frequently than we have in the past, like every 2 years, if not every year.
Someone put in the Q&A here, what is SSP? I know you have it in your charts. I just want to be clear for the audience. What is SSP in your
Well,
charts?
hopefully I said it correctly, because sometimes I say shared sociopathic pathways, but actually it's shared socioeconomic pathways. It's a mouthful. You know, just like scientists love acronyms, as Dr. Phil already told us. And these were put together by the IPCC in order to like categorize their projections. So they have these different assumptions.
Okay, thank you for that. So Phil, back to you on kind of your job. And so, you know, you get this fanfare on June 1st, and then June 2nd, you have your new forecast coming out. And so I imagine you're pretty busy through November, through the hurricane season. Tell us about your off-season modeling and what you're doing kind of when hurricanes aren't rearing their ugly head for all of us to see.
Yeah, so we do a variety of different things. So one of the things we do during the off seasons is, so these hurricane forecasts, you know, you put out the numbers. I didn't get into today, but we have a variety of different models that we use to come up with our forecasts. So we use historical weather and climate data. We use model forecasts from various climate models. So not on the, you know, say 50 to 100 years, like the climate projections, but climate models forecasting out several months. And those models can give us some information about how kind of the water temperatures and the wind patterns are going to look like for the hurricane season. So we're always working on model development. We also do a lot of work on trying to better understand, you know, what makes hurricanes tick. And well, I didn't talk about it much in my presentation, also looking at basically how hurricanes have changed in the past and how they're likely to change in the future. So looking at some of these questions that Karen and Eric have already talked about, you know, how hurricanes are going to change in the future, how that's going to change the drivers of damage. We also do a lot of work on, you know, what are the drivers of the damage on an individual hurricane season as well, you know, El Nino versus La Nina and other climate patterns.
So take us inside the hurricane. You always hear about the eye of the hurricane, Phil, and you hear that planes fly into the eye of the hurricane. Tell us how this works. Who's flying those planes? How do they collect the data about the wind speed? So give us kind of a behind the scenes look at when the hurricane is happening. What is NOAA doing? What's the government doing? What is your organization doing? And tell us about the guy who has to go fly that plane into the eye of the hurricane.
Well, unfortunately, I've yet to be on one of those. I would love to be on one of the Hurricane Hunter aircraft, so I can't actually tell you exactly what it's like to fly through a hurricane. But there are, so these aircraft, basically some of those aircraft reconnaissance started all the way back in the early 1940s. A guy basically got his navigator and was like, hey, we're gonna go fly into a hurricane off the coast of Texas. And they realized, hey, we survived and it was pretty cool. So let's go and actually try to get better data. So basically when hurricanes are approaching either the United States or they're flying or potentially impacting the Caribbean or Central America, they will fly planes into storms. And a lot of these are flown by the US Air Force. There's also planes flown by NOAA. And so they will get really important information, basically information on the winds in the hurricane. They'll also get information on what the pressure pattern is like in the hurricane, since a lower pressure is associated with generally a stronger storm and actually correlates better with the damage than the actual wind speed, because it takes into account the size of the storm. And then what they'll do is they'll relay that information to people on the ground, hurricane center forecasters and other interested parties. And so you actually can track the planes when they're flying into the storm and see the data that they're gathering in real time. There's pretty cool devices. So they'll fly into a hurricane at about 10,000 feet. And as they fly into the hurricane, what they do is they actually have a device that will actually look at the churning up of the ocean water. And basically measuring effectively the amount of sea spray. So obviously the stronger the hurricane, the stronger the winds, the more sea spray. And they'll use that to actually estimate how strong the winds are in the hurricane. So it's a really cool method. And so when we aren't flying planes into hurricanes, we're estimating hurricane intensity from satellite, which works reasonably well, but getting the plane in there and getting kind of that ground truth information really does help pinpoint really how strong these storms are. And that information is valuable because then it goes into the forecast models that are there, what the Hurricane Center then uses for their forecast of future intensity and track of the tropical cyclone.
Okay. Karen, we have a question coming in from the audience. Does your company have a proprietary model platform, or is it a blended model using RMS or AIR, other?
Oh, yeah, no, we have our own proprietary models that we've been developing over the past several years. So no, we have our own proprietary models, and we feel that they're kind of the second generation of models. They're more transparent, they're more efficient, and seems to be, we have evidence that they're more accurate, which are what companies want. So, so we have our own.
Okay, wonderful. Another question coming in for Phil here. So let's talk about La Nina forecast. So this definitely affects the industry. Does the La Nina forecast bode well for a wet, rainy season on the West Coast, or does it indicate a dry season for the West Coast, or can you make that correlation?
Well, and so, in general, the wet season again will be coming up this fall and winter. And so at this point, the odds of what's going to happen this winter is more uncertain. But if we were to get a La Nina, continued La Nina, typically kind of the canonical pattern is that makes for a fairly wet northwestern United States and dry in the southwest US. But there's a lot of caveats to that. As you get farther away from, so El Nino and La Nina happens in the tropical Pacific, there's these kind of relationships that happen most of the time, but it's not necessarily a slam dunk. For example, last year was obviously, we had La Nina throughout the winter from 2021 into 2022. And if you look at, say, California, it was an extremely wet December, like record rain, record snow in the mountains, and then it got extremely dry after that. So, they kind of have these relationships that work reasonably well most of the time. But even if, say, we do get La Nina again, it's not a guarantee, say, that it's going to be super wet in the Pacific Northwest and dry in the Southwest. There's other climate factors and just weather patterns that come into play there.
Okay, all right, Eric, here's one for you. Both RMS and AIR have secondary characteristic fields for IBHS. When will fortified recognition, the premium credits, more favorable terms, be integrated into the underwriting process? Good question.
Great, good question. We have integrated at Travelers. We do offer in our homeowners product a fortified discount. And so that's with our Quantum 2 product, homeowners product, that's available in most states. So some states may not have that discount available yet. So let me couch that by saying most states offer that. And we try and do these. Travelers Institute is a broad audience here. Full transparency, many insurance companies today will offer a fortified discount. And that's what we want. We want society to change. We want folks to be willing to do Code Plus. And so those discounts are available. I would contact your agent.
Okay, well said. Phil, how about this one for you? How much can a catastrophe such as a massive volcano eruption or an earthquake and tsunami mixing into the water affect the weather, and how fast?
Well, so let me talk about this from the hurricane perspective, because I know we're running out of time. So if you get a massive volcanic eruption in the tropics, that's usually what will actually cause, basically you get enough basically aerosols ejected high up into the atmosphere that will then cause significant cooling, and that could potentially overall reduce, say, the amount of Atlantic hurricane activity you get. A lot of the big volcanic eruptions we've had recently, obviously there wasn't one in Iceland. I'm not going to try to pronounce that volcano's name. That's basically too far poleward. That basically it gets mixed out a lot faster in the mid latitudes than it does in the tropics. We've had a couple more recently, but the amount of basically ash that's been injected hasn't been enough to really cause more than just a very, very brief, couple of days kind of cooling. But if you do get a really, really big volcanic eruption, there are some ideas. Basically, if you have a big volcanic eruption, that basically the increase in the aerosols basically will cause reflection of the sun. Basically, the radiation that's coming from the sun, more of that will get reflected out into space, leading to cooler waters and in general a quieter overall hurricane season. But there's not a lot of those, thankfully, that have happened. So the data is fairly limited.
Okay, great. Eric, last one for you. Is Travelers involved in any parametric products or research? And what is parametric?
Yeah, so parametric's going to be, we are experimenting with parametric. And so today what happens is if you have a loss at your home, you have to have physical damage at your home to trigger coverage, your home or business to trigger coverage. And so sometimes, you know, if you have a power outage for a business with an extended period of time, you know, folks want to know that they have coverage, not just from physical damage. So they may decide as a business, they want parametric insurance. And so parametric would be tied to, say, wind speed triggers. And so say there's a wind speed trigger with an anemometer in a certain location in a state, it would trigger coverage based on wind speeds instead of based on physical damage at your property location. And so I think parametric is a very intriguing new insurance product. It's just hard to explain to the average consumer. And so I think the parametric products will be there for more sophisticated, larger insureds over time. I hope that market comes out and gets bigger over time. It's very intriguing.
Yeah, it's very innovative, very, very fascinating. I can't believe it, the hour just flew by. So I want to thank our speakers tremendously. The good news is that we have a replay that will come out in the next week or so. So watch your inboxes. This was a terrific session. So Eric, Karen, Phil, thank you so very much for your time, your insights. And we're going to look tomorrow morning at 10 a.m. Eastern for that updated forecast. It doesn't sound like you're going to improve it. It sounds like we might have to batten down the hatches. So thank you all. Appreciate it. And to my viewers and listeners, I want to talk about the next few weeks at the Travelers Institute. Next Wednesday, we have a session on cybersecurity again. And this one's specifically about how to build your incident response plan. So after you've been hacked, what is your plan? And we're going to talk specifically about that next Wednesday, June 8th. And then on June 29th, we're going to talk about the exponential rise of nuclear verdicts. Everyone is talking about this. We have two experts, inside expert at Travelers and an outside expert, to talk about the rise of nuclear verdicts and what we can all do about it. And you can register for any of these programs at travelersinstitute.org. You can connect with me on LinkedIn. I'm very active on LinkedIn, posting our replays and our invitations. Again, these are all free and open to the public, so share our invitations with your friends. And if you haven't already, take a moment in the chat. We have a link to the survey about today's program. So let us know your thoughts and who else you might want to see on our show. Have a terrific week. And again, thanks to my terrific speakers. You all were terrific.